My name is David Yang. I'm the Executive Director for AAA Foundation for Traffic Safety. So it's really exciting for me to see there's one session here at this meeting that's kind of putting a focus and dedication of looking to data that's related to traffic safety. And to me is all the stuff we do related to transportation, safety is probably one of the most important thing, in my opinion, saving lives. So this morning we got 3 presenters. One is from Federal Highway, two are from the state of Maryland. So really, I think that if you live in the DC area, you can probably relate to a lot of stuff they are talking about here. So without further ado, let me introduce our first speaker, Dr. Wei Zhang from Federal Highway Administration. So Wei's topic, he's actually going to tell us about basically how to visualize kind of crash. And based on crash, based on his research, hopefully we can get a new appreciation about how to see crashes based on his presentation. So without further ado, Wei?
Thank you. My name is Wei Zhang. I'm with Federal Highway Administration. I'm the Intersection Safety R&D Program Manager. I've been doing this job for 11 years. Okay. So the topic is visual analytic platform for quantifying operational and societal impact of vehicle crashes. My co-author is one postdoc working with me. His name is Dr. Lin Qiao. All right. Okay. The goal. Why do we want to develop this? And the goal is, if you identify a crash event or any other event that gave you the time and location, this tool is going to find the naturalistic driving trips instantly. That not 1 month, 2 months. This tool, the goal is we will find the trips from gazillions of gigabytes of data. We'll find those trips. And typically, this task to finding the NDS trips for the study you want, this is for many studies, if you work with SHRP2 data, any other, this is the biggest component in terms of the time it takes, in terms of the cost it takes, okay? And the background is, right now there are many transportation safety-related data sets that have been accumulated, such as the SHRP2 safety study, the safety pilot, the national performance, there's measurement. It's a lot of transportation and safety-related big data sets are being accumulated. And this data are huge. Okay, so the daily software we use cannot even open this kind of data. So to analyze this kind of data, you need some kind of specialized tools, okay? And if you know how to analyze data, you get a lot of knowledge out of it, okay? It provides insight of how you can improve your roadway design, how you handle congestion, and how you deal with safety, and what does give you more, accurate insight about what's maybe the user cost through analyzing this data, okay? And so the goal of this study is to develop a specialized tool that enables researchers to do this type of study. And so the research question we ask when we start is, with basically what are the typical delays and user costs of traffic crash, different severity, okay, on different type of roadway facilities. And this sounds simple, but when you really dive into it, it's not that simple, because you have different type of roadways. You have freeways, you have major arterial road, minor arterial road, you have local road. And for each type of roadway, you have the roadway segment. For freeway, you have interchange. For other type of road, you have intersections. And you need to consider if there's a crash, what is delay caused in the same direction of travel or the opposite direction of travel, okay? And also for non-freeway facilities, there are other kind of delays. Traffic control delays caused by signal, caused by stop sign, yield sign, okay? And we need to know how to separate those delays from the delays caused by crash, okay? And so once we know we have a good picture to answer the above question in the previous slide, then it enables us to quantify the operational impact and user cost of traffic crash for different, severity on different type of roadways. And it enable us to do better planning for incident response, and also prioritize action plans to roadway improvement. Because if you know there are certain locations tend to have a lot of crash, every time it has a crash, it has a long delay, and that has a significant user cost. Those areas you can say I need to prioritize. Either I improve my incident response to clear the incident faster, or if the event is caused by infrastructure deficiency, I better fix the infrastructure problem. And it definitely, by doing this, it enables us to do better roadway design. And the data source we use to do this study, we use the Michigan statewide crash data and safety pilot model deployment data. Okay, and the methodology that I'm going to present, even though I use these two data sets, it applies universally. It doesn't matter where the data come from. Okay. So the safety pilot data, this is done in Ann Arbor, Michigan, and they have a total of about 2,843 instrument vehicles, and different type. These are different vehicle types that's been instrumented to collect different type of data, both text data and video data and audio data. Okay, and in this study we only use the text data. Okay. And so this is just give you a sense of comparison between safety pilot data and SHRP2 naturalistic driving study data. Okay, the safety pilot data at Ann Arbor, at one site, one location, we have about 29 instrument vehicles, and they operate a continuous data collection for 12 months. 2 months data is freely available, and just the text data alone is 300 gigabytes. Okay. For the SHRP2 study, they have 6 sites around the country, and each site has anywhere between 150 to 450 vehicles. Again, they continuously operate for about a year, but you do need to pay a fee to get SHRP2 NDS data. Initially, we plan to use the data from Seattle Road Information Safety System, which has crash data, and also the SHRP2 NDS data. And then we found out, I actually went through the process, but then we figured out there's a better data set, because this safety pilot data, one side has almost 3,000 vehicles. All the other SHRP2 data, they have much less data. So in terms of the richness of the naturalistic driving data, the safety pilot is much richer. That's why we eventually decided to use the safety pilot data. And how do we access data? The crash data is manageable. It's not that big. It's very big, a lot of columns, but the number of records are not that big. Okay, so there's a map. There's a crash. The way we do it, you transfer the map into a 2D longitude space, and then the vertical that you have the time. Okay, imagine if you have a lot of vehicles in every moment. There's a lot of vehicles, and you stack them up. Okay, that's basically, if you look down, that gives you the trace of each trip. Okay, so the way we conceive to access data is the crash event gave us the time and location, and then based on that time and location, we go to this massive naturalistic trip data to extract the trip that's relevant within the same area of the crash event within a certain time frame, within 3 hours, within 2 hours from the crash event. And that's the type of data we want to extract. Once we can do that, we can do all the studies that we need to do. And because the NDS trip, this is a massive data file, big flag file. You have to figure out a way to partition the data, to index data, to enable you to have the real-time access. Okay, so by doing that, this is the data collection. The index, they collect data every 1/10 of a second, 10 hertz data, and that data is too big. So for our study, because the crash event is going to last more than 10 seconds, right? So we downsize the data. We do a data thinning. Every 100 data point, we extract 1 data point, save into a different file. This is a different, additional sampling. Basically, reduce the the size of trip data by 100. So reduces dramatically. 1 gigabyte is reduced to 10 megabyte. Okay, but still have the detail of the trip. We don't lose any trip details. And then we also do a data indexing. We archive the data by day. For our study, each data file after I do the data cleaning, it's about 30 megabytes. That's manageable. Okay, and then we also do some query optimization to increase the speed of data access. And when we do this study, we put together some kind of functional specification, what this system must be able to do. Okay, this system, we said they should be enable the trip selection by time and location, because the event gave us time and location. And this application need to be built on the GIS platform, because the data seems to be complex, but once you put it onto the map, it becomes much simpler. Okay, and this application should also allow users to make judgment and to do some kind of manual data entry. And it also needs to enable the export of merged data so that the user can take it out to do standalone analysis. And we also need to do some kind of data structure design that ensures fast data access and without losing any detail of the trip information. Okay. And so based on those functional spec, we build an application. I try to do a real-time demo, but there's a security reason it will not allow me to run. But so I'll just explain the application through the PowerPoint. So basically, this is the application. This is the interface. So what do you see here? This is a freeway segment. There's a crash here. Okay, this is a major injury crash. The data point, the distance, the time interval between any two data points is 10 seconds. So if you see this, the spacing between two data points are closer, that means they have slower speed because the time interval is the same. Okay, so by looking at here, you can see, there's a vehicle coming from here at relatively higher speed, and then there's a crash, and this is the queuing condition. Okay, so visually you can see, so from here the timestamp of the crash, from here the timestamp of this trip. And this, when you do this, if I look at the other trips, gradually I'll be able to determine how long is the duration of this crash event. Okay, and from the queuing condition, you can also have a sense of, how long was the influence zone, how long is the queue. Okay, the next example is more specific. This is again on the freeway. This is a fatal incident, and this is an on-ramp. This is an off-ramp. So this segment is a weaving segment. Okay, so you see there's a car. This is the time of the crash was 1:30 p.m. and the time of this trip right now I'm showing here. This happened on the same day, at same location, but at 2 p.m. So this is about 30 minutes after the crash event. You see this car came from here and do an on-ramp and then stop here. Okay, because the queue is so long that this driver decided to do a detour, get on the off-ramp and do a detour and then came back to the same road. Okay, and this is the next one. This is the same crash, but this was 4 p.m. So this is almost 2.5 hours after the crash event. And you see this trip is on the opposite direction of the crash. This is a rubbernecking event. Okay, so this crash actually happened on the other side of the freeway. Drivers on this side slowing down, and and you can see this distance. This is 900 feet. This distance from here to here, this is probably more than a mile. Okay, it's almost impact the other interchange. And what this tells us is when you do this kind of study, not only you should look out for trips that's passing through this location. You probably should also look trips that on this road, because there's on-ramp that vehicles trying to get there may be affected. And for this trip alone, the queue back up to this interchange area. So definitely, you probably also need to look at trips that's going through the other area. So this visual tool tells you, when you do this kind of study, you can find the duration of the crash, and you can also find how long is the influence area, and then you can determine, what other trips you need to study, okay? And this example, this is on a non-freeway segment. This is right here. There's a crash right here. Okay, this is a signal intersection. This is a two-way stop control intersection. You see the car come from this direction. They came at 33 miles per hour, but they are stopped here. Okay, and then move on. And this control, when you look at this location, this control may not be completely caused by the crash. It could be also caused by the traffic signal here. So when we study non-freeway facilities, we need to figure out a way how to remove the delays that's caused by traffic control device. And this example, this is a crash. This is a signal intersection near University of Michigan. So the crash happened right here. Okay, there's a traffic signal. On the other side, you see there's a vehicle come here, and then basically just stopped here. And this is, again, this may be a service vehicle. And because we have other trips that go through this location, they can move, but this car basically come here, he stopped here. And this may be one of the police cars, what that type of vehicle instrumented, but come here to help maybe handle the crash event. So in this case, when you study the trips data, we need to distinguish between, if it's just a regular passenger car, that's okay, because but if one of this kind of service vehicle, that vehicle may come here to help clear the event, and that vehicle stop here, this may not be the true delay, okay? So this is the lessons learned. When we do this kind of study, we use two types of data. One is the event data. In this case, we use crash event, but you can find any other event. The event gave you time and location, okay? And then based on the time and location, you find the trips. The trip data, we have different, in this case, we use naturalistic driving data. And in previous presentation, you see you have prop data, or you have permanent counting station data. All this data are necessary. In this study, we can accurately determine the duration of the impact and the length of impact. But when I try to compute the user cost, I need to know how many vehicles typically go through this location during that hour period that the impact by this crash. And then I can apply a dollar value to the to the user, $20 per hour, whatever, to get to quantify the user cost. And again, when you analyze non-freeway facilities, we need to separate the delay caused by crash and also the delay caused by other factors including traffic control device, including service vehicles. Those you need to be able to do that, okay? And then how rich, this is the data we use is very big. These are massive data, okay? 2,000 vehicles in a small community. The data is so huge, you think you have enough information. But actually, when you try to match this naturalistic driving data to real event, you still don't have enough data. In this whole area, we found only 7 fatal crash. 5 of them happened on non-freeway, relatively local road. We cannot find enough trip data go through that location. We have only 2 fatal crash on freeway that we can find enough trip data to make a quantifying determination. So even with the data we have, we think it's so big, it still doesn't give you, the information you need. And so through this study, you see the value of visualization. You have to use this kind of tool to determine the impact, where you should find your trip data, okay? And so that's basically the conclusion is the visual analytic platform that we developed in this study achieved the design objectives that we want, and it enables us to do the type of study that we need to do. And basically, I just need to find enough fatal crash, enough trips through each fatal crash to determine the impact of fatal crash. And then I just found enough number of serious injury crash, do the same thing, and do an average, okay? And we need to develop something to fast data access, but the application we determine we can retrieve the trips from 300 gigabyte of data instantly. The moment you define the location and time, we can grab the trip, okay? And visualization enables a more accurate determination of the duration and congestion impact of different crash event. Since I cannot do the real-time demonstration, but I would entertain any question if you have. Okay.
All right, Wei, thank you. So, are there any questions for Wei about the platform he has just presented? Pat.
Thank you. So the objective of your study is to estimate the delay
Yes.
and user costs
Right.
of any incidents.
Yes.
So we haven't talked about the user cost yet, right?
No, this is the
I missed
enabling
it.
tool. This is we have to have this kind of tool to do that type of study. Yeah.
Okay. So the things that I haven't been able to connect from your presentation is, why do you need to use the NDS to identify a vehicle or incidents in the safety pilot? Or did I miss something?
No, so we use crash data.
What crash data?
Yes.
What? Which one? NDS?
No,
Which one?
we use the event first. So this crash data is from Michigan.
From
This is-
safety pilot.
Not safe.
Oh,
this
oh,
is separate
okay.
data.
All
So
right.
The crash, if I found any crash, that crash tell me the location and the time, right?
Yes.
So that gave me a reference where I should. Then all I need to go to the NDS data. I found the trips that goes through the same location, within plus minus within 2 hours, within 3 hours from the crash event, so that I can know what's the traffic condition before the crash event, what's the traffic condition after the crash event.
Okay.
Okay.
All right.
All right. So I don't know if there's any people in the audience here that's from like a state DOT or so forth, but I guess one of the questions as I was going through, I actually have two questions, and I just realized I'm looking at this. This says Danish interpretation system, but it's not translating my English, so that's good. That's a joke, by the way. First of all, is this platform available for other people to use, or is this more kind of in-house within Federal Highway?
This is everything is developed in-house.
Okay.
So with the previous presentation you saw, they use the Tableau, they use Hadoop,
Right.
those big softwares, and we don't have those software. We develop everything purely in-house without ArcGIS. Everything it's portable. So this is serve our purpose.
Okay.
Okay.
And so, does Federal Highway plan to use this, share this platform with other people in the future?
This can be, yes. This is this is not that need some customization. But
Okay.
the methodology is the same basically. You have invent how you find the trips.
Right.
Okay.
And I guess my follow-up question, this is for people who, if I'm a state DOT, right, or a city, I guess for me is, okay, so I'm looking at this and I'm gonna say, okay, how can I use this to help me to solve the problem? So do you have any thoughts on what's the implication of this tool in the future?
Well, this tool can help, the researchers, they know how to analyze the data, okay? But the biggest obstacle for researchers, they don't have access to this data. You have this massive data, okay?
Mm-hmm.
They cannot open it. And someone hosts this data, they need to ask, this is, you go to SHRP2, it can take many months or a year to get the data. Okay, so this is basically shorten the time you have, the waiting time. It's basically, if you're a researcher, enable you to get to the data you need in a much shorter time period, within a few minutes, right? And then so that the remaining thing you know how to do. But for a lot of researchers, just to get the data, this is the biggest time consuming activity. Okay.
Question?
Yeah, I have two questions. My first is, how long did this take from start to finish for you to ingest the data and then complete these visuals? The second question is, building off of Pat's, is what would be the next steps from your perspective? You've built this great foundational tool.
Okay.
What would be the next powerful visualization piece to it?
You mean, okay, the first question for this application, or, okay, for this application, once you select the crash, you define an area.
Yeah.
We can find other trips. The current
Sorry,
computer.
I meant from, like, you literally went and asked permission to have the data, you ingested it,
Okay.
thinned it down, and then you created it. So the project time.
The project time. This one takes us probably 3-4 months, but this is because we have done other big data research, so this is built on previous work. It's not everything from scratch. Okay.
You got a second question,
The
right?
second question is how to, this is mainly if you can find the trips, you can study the very detailed characteristics of each trip. For example, this is, you can see the rubbernecking in fact, right? Okay, and then that tells you, maybe I should look at the trips that's going through totally different road. Okay, maybe those trips are affected.
Yeah.
And then so when you compute your user count, not only you need to look at the loop detector data, the traffic count on this road, you probably should also look at how many vehicles affect on other road. And that will give you a better idea of what's the true user cost. Because otherwise you just focus on this segment that may or may not be true.
Have you defined metrics for what user cost would be?
The
Or
user
is that
cost,
just the-
the user cost meant you find out how many drivers will be affected. And then for that area, you say typical hourly value would be $20 per hour or something like that. You just multiply that dollar value to it. And you assume each vehicle has 1.5 or whatever number of people in it.
Okay.
Okay.
All right.
Thank you.
Wei. Thank you.
Okay.